Hi. A lot of things happened this weekend at Sharon's tournament with APES and with the EGS system. And one of the things I heard, I think Larry said that one of these lenses, these LED lenses, got crushed. So I want to show how that can happen, how we can prevent it, and a potential design modification I can do to the enclosure to prevent it if necessary. So this is just a picture of the pass pole or start pole with the photo sensors in here. The last one is right below the APES trigger box, and there's actually an LED that this box covered that changes from red to green whenever a dog breaks the beam, then goes back to green again. So the way APES knows to tell the cameras, send a signal to the cameras to expose, is by sensing when that LED changes from from green to red. Let's go look at one of these lens covers up close. If you look at it, you can see it extrudes a bit from the surface of the PVC, of the FarmTech PVC. It's not recessed in, it actually sticks out. If we go back here and look underneath the trigger box, you can see there's some clearance, but there's not a lot of clearance between the two. This is the LED has a cover. This is the green red LED, changes from green to red when the beam is broken, and this is just the top photo sensors. If we look at that a little bit closer, we can see, yeah, there is some clearance, but there's not very darn much. So it wouldn't take much for there to be a problem with the box when you try to slide it down over hitting that lens. If you look at the lens itself, it's not just a cylinder all the way back. There's actually a little bevel, so it goes in the holes and snaps. But it's a sloppy fit. It has to be a sloppy fit. The hole has to be slightly bigger than the barrel of this lens, and what happens is it can ride up a little bit up on this bevel and can cause the thing to that's have a little slop, so this lens can be extruding more than normal if it's a sloppier hole fit, or the PVC itself. Its outside diameter PVC is the only thing that's controlled. The inside can vary quite a bit. So from pole to pole, there can be a lot of variability in the inside diameter, which means there can be more slop in how this lens slides in and out, which means some of them can be loose and stick out and obstruct pushing the trigger cap on top. Here's just another view of what that looks like. I don't show the hole in the PVC that this snaps into, but hopefully you can get the idea what's going on. So just check to push them in, I guess is the message. Now, nowadays I have a 3D printer. I didn't have one back when I made Sharon systems and several others. So this was really just the cap itself was just a piece of PVC cut, and just run it through a table saw. And this critical dimension, I couldn't really control it that well. I just got as close as I could to get it as good a signal. And so it's very likely that some are much tighter than others. So there's a good chance that one that was in Sharon's system is one of the an exceptionally tight one. Could either be that or this lens was sticking out a little further than most. I use these at Can-Am. I didn't have a problem, but I'm kind of in the habit of always just pushing these in good and tight before I slide it down. So if we need to do something, it's very easy just to 3D print different versions of these covers where I just cut out a thing and give it some more clearance. Easy to do, but there is a downside because it lets in more ambient light. That's never going to be a problem except at Can-Am. What happens at Can-Am is the sun comes up, gets a certain time in the morning, shines through the window, and shines directly on these pass poles. And as it is, I have to go in and during that 5 minutes, maybe 10 minutes of time when the sun is shining directly on this thing, I'll have to get a piece of duct tape or whatever I can find handy. Typically it's whatever they tape the mats down with, and just put a piece of tape just to block it here on these sides. This side's cover. So I think that means for sure I'd have to tape it if I add this little hole here. But that's better than having these things so hard to get off and on that we damage things. There's just another view of how that would give you the clearance. So there'd be no issue sliding this thing on and off at all. I guess I should have shown there's quite a bit of clearance between the pole, and this guy. It does seat in the top of it rather firmly. There's an inner ring what I call retainer in the top of this thing that catches the top of the pole. So the other thing I wanted to show you is this gel we're talking about, that the idea being, since we're trying to sense a transition between, let me go to it, this is the gel, it's just super glued in the back of this plastic box. Sometimes I've actually wrapped it around the sides of the photo sensor, but lately I just glue it this way. The idea being, if we filter out everything but red or near red light, then the transition when it goes from red to green, green will appear, when it transition from green to red, red will appear brighter to the photo sensor, and I trigger on an increasing signal level to trigger the cameras. So if this comes out, which is what happened this weekend or sometime, then apparently the photo sensor can think that green light is brighter than the red light, and when that happens, instead of triggering when the dog first breaks the beam, it triggers some unknown time after the dog is out of the beam, which makes it look delayed. So that was what was happening. Tammy and Dick got, when Tammy noticed really early that this was missing, she suggested doing that. I didn't think it was that critical. I'd used these things without that in the past when I first started doing these without any problem. So I was a little skeptical, but it turned out that that's what the problem was. Anyway, that's when we talk about gel, that's what we're talking about. So one of the things that we're going to always want to do when we start out is just, you can see back up in here, and you can see that gel. So especially when the cap's off, when the pole's gone, it's really easy to look back up in there and see the gel. Or that it's not there. The other thing I wanted to point out is this, these new triggers. Like I said, I 3D print this cylinder, the box lid, and this cap. And one of the things I've done in the last several years, I started using a much better RF transceiver. It's better because number one, the jack doesn't come off. The other ones had a push-on jack that tended to come off, and then I ended up trying to JB weld them back on so they wouldn't come off. Anyway, this is it's all one-piece jack, so that problem's gone. And also, it's just a much better transceiver. It's shielded, and it's got a range that's farther than I've been able to test before getting out of range. Somewhere between 1.25 and 1/2 mile I've tested. So it's really super good, and that's what I'm going to. But what that means is the cap itself, in order to have a place, let's hide that. In order to have a place to go away. To mount it, there's a flat edge here. So it's not a cylinder going all the way around. I had to have a place to mount this. So what that means is, it used to be you could put this cap on and rotate at any angle, and you could push it down. But now you have to make sure the jack that comes out top is at the 12 o'clock position, or lined up like this, so that bevel, that flat spot, will actually line up with this. There's a hole in the PVC here, so it's important that flat spot that I mount the transceiver on lines up with that. So you can't just push it on any way like you used to do. Mike Smith, I'll be sending you new triggers that have that, new transceivers, this whole assembly. Sharon, you already have caps like this. But I reused, when I did this, I don't know, a couple Can-Ams ago, I reused your PVC part of the trigger. I didn't 3D print new ones, and I'll be giving you some 3D printed ones, so you'll have more precision control over this, how far this flat surface is on the cut. I'm hoping that's going to resolve the problem. I'll have to start looking at more closely and look at as many different poles as can be with the new 3D printed ones, and swap out anybody who's got the manually cut PVC versus 3D printed trigger cylinders, so that we can avoid this issue in the future.